Hello and happy Friday. So today we're going to be doing part 2 of inventory modeling. This is all based on a question I wrote for the Financial Modeling World Cup round 2 last weekend. So the last video we talked about the first part of the model, which was thinking about how much you make in response to demand, when to scale up production, how to manage that so as to not to have too much inventory on hand, but to be able to meet all the demand, blah, blah, blah. So today's piece is going to be talking about first just a simple thing on figuring out the unit costs and the sales price and hence the total costs and revenues, and then the bigger piece is going to be talking about how you value that inventory under FIFO and LIFO. I'll talk a little bit about what those mean conceptually and mostly about the kind of ins and outs of how to model them. Let's just run through the model assumptions. So first of all, I'm just going to take the units produced and units sold as inputs this time. So last time around we worked out how to model those. Today they're just the starting point. The other assumptions we've got basically we're a factory, we make things. People work on the things, we pay them $23.25 an hour. That's going to grow by 7% each new calendar year. It takes 8.1 hours of labor time to make a thing, and for every whole 100,000 things we have made, that goes down by 2 percentage points. So if we've made 500,000 things, then the next one is going to take 10% less than that 8.1. If we've made 1,000,000 things, the next one is going to take 20% less. It's obviously an extremely simplified experience curve, and don't ask what happens if we make more than 5 million things, because it's all very mysterious. We need materials that cost $320 per unit, and that is subject to inflation of 1% per quarter. That's all the costs we have to worry about are materials and labor. And then we charge a markup, initially 20% above the cost per unit, and then that's going to erode a little bit every year over time. And then we round to the nearest dollar. So, much like the first part, very, very simple assumptions. Almost to the point of being totally unrealistic. But so let's quickly model that piece, and then we'll get into the inventory valuation. So first things first, let's look at wages. So we're going to start off with the starting wage, of course. I'm going to still a stickler for formatting. So, and then I'm going to say equals if the month of this is equal to 3, which means I'm at the end of the first quarter of the year, i.e. that's when in the first quarter things go up, then 1 plus that wage growth, otherwise 1 times my previous F9. Copy that across, so let's see, it goes up in Q1 of 24, it goes up in Q1 of 25, and so on. That's exactly what we want. Okay, production time. So let's just do cumulative production before this Q. And that's going to be sum back to that column. Then the production time is going to be, I've given these names, so prod time start plus efficiency change times, what do I call it, efficiency change multiple, efficiency gain multiple. Sorry, so I want to round down this number divided by the efficiency gain multiple. So in other words, how many whole multiples of 100,000 have I got to, and I multiply that by my minus 2%. This is my number of hours. So let's see, I said once we've made 500,000, we should be doing it 10%. Oh, sorry. So I am subtracting this. I should be multiplying by 1 plus that. And now hopefully it'll check out. So like I said, when we first pass 500,000, we should be now 10% less. So just a quick sense check. We are 10% less. Good. So that's the production time. So then labor cost, well, let's just say cost per unit. Labor, spell labor like an American now, like I do many things like an American now. That's that. I guess we'll give that a couple of decimal places since we're doing per unit. And then materials. And again, this is going to be giving them names, so mat cost start. And I'm going to format that differently because it's different from the formula I'm going to have for the rest of the row. And then I have a quarterly inflation, so that's just going to be equals that times 1 plus mat cost growth. I'll carry that across. So it's going up by 1% a quarter, which is what we want. So then we'll say total. And we'll give that 2 decimal places as well. And a line. Alright, so then I'm going to have, let's do total costs. We'll do the same thing again, labor materials total. And now this is just going to be this times the number of units produced. Now I do not want my decimal places anymore. Okay, and then I'm going to have my sales price. Sorry, no, I'm going to have my markup. I need to figure out how that changes. And then I'm going to have my sales price. And then I'm going to have my sales. So my markup starts off at 20%. And again, different formula in the first column, so I'll make that red. And it goes down by 0.25% each new calendar year. So I'm going to say this minus if month of this equals 3, then what do I call it? Markup grow, otherwise 0. Actually, I think I have already a minus sign on it, so it's going to be plus. Let's just double check that. Yes, so it goes down by 0.25% every time I tick into a new year. And in the end, it's gone down 9 times because it doesn't drop in the first year. So that makes sense. Good. So then my sales price is going to be round. Was I rounding up or down? Or I think I was just rounding to the nearest dollar. Okay, so I'm going to say round the unit cost times 1 plus the markup to 0 decimal places. And then my sales is just going to be my units sold times sales price. Beautiful. So I've included in here the questions from the round, just to make sure that I'm getting this right and go away, and keeping myself on track. So let's take a look. When is materials cost first above $400 per unit? And it is, oops, went right past it. There we go, in Q4 28. So that's exactly what we were expecting. Wages in 2029. Wages here, 2029, 34.89, and it is good. Production time in Q3 30. Q3 is here, so it's 5.35 hours, and it is good. Highest labor spend. So this is just a nice little kind of reality check. You've got rising wage costs, but falling production time. So your peak wage costs are not. It's not at the end or at the beginning. It's somewhere in the middle. But we can just say max of this line here. And yep, that's working out. Sales price in Q2 2025. 2025 Q2 sales price 655. And then total sales revenue. The sum of this. Okay, so that all checks out. So that's, like I said, that's kind of the straightforward part. So now let's talk about FIFO and LIFO. So I don't mean this to be primarily an accounting tutorial because that's not really my thing, but I will try to give you a quick explanation of what these things are, and then I'll talk in a little more depth about how to model them in Excel. So just very simple model here. So we have, sorry, I was meant to change this and then I didn't get around to doing it beforehand. So we're going to just have a simple model where we have 4 quarters. We produce 10 units in each quarter. The cost gradually goes up. Sorry, I'm also going to replace. I originally set this up with 100, but then I had 10 spaces and it was just getting confusing. So hopefully I can. Should really have done this first, but never mind. You don't come here for the production values, I know that, because otherwise you wouldn't be here. So we produce 10 units in each quarter. The cost goes up 60, 70, 80, 90, and we sell 7 units the first quarter, then 8, then 11, then 9. So let's look at what that looks like. So we've got these boxes for each quarter, 1 box per unit produced, and we're going to fill them in as we go. So first we have Q1 production, so we make 10 units and they each cost 60. Then we have Q1 sales, so we sell 7 of them. So our closing inventory is just the sum of those 360s, 180, and our cost of goods sold is the difference. So we got rid of these 7 units here, so that sums to 420. So we have cost of goods sold of 420, inventory of 180. So far, no difference between first in, first out, last in, first out, because every unit is of the same cost. So now, whoops, sorry, wrong page. So now we add our Q2 production. We make 10 units that cost 70 each, and this is where the two methods split up. So last in, first out means that we sell the newer units first. So here's we're selling 8 units, so we're going to sell these 8. We keep doing that. We drop those, and this is what's left. And then again, we've got inventory, 360s, 270s. That's your 320 there, and your cost of goods sold is the 8 units at 70, which is 560. So then we add our Q3 production, make 10 units at 80. Now we're going to sell 11. So we're going to sell all of the newest things plus one of the previous thing, which will get us down to here. So again, our closing inventory is 250 and our COGS is 800 there plus 70, 870. Then we add our Q4 production. We make 10 units at a cost of 90, and then we sell the 9 newest ones. Again, last in is first out, and we're left with this. So our closing inventory is a value of 340, and our cost of goods sold is 810. So now let's compare and contrast. If we do the same thing under FIFO, again, Q1 production stays the same, Q1 sales stays the same. We add our Q2 production, that's fine. And now, first in, first out. So first we're going to sell 3 of these, and then we're going to sell 5 of these. So we do that, we're left here. So now our inventory is 350, and our COGS is 530. If you compare to LIFO, we had slightly lower inventory value, slightly higher cost of goods sold. So if you think about this in terms of impact on your 3 statements, here you've got a larger, here FIFO, you've got a larger balance sheet asset and a higher profitability. So people love to talk to their shareholders in FIFO language because in the real world costs are generally kind of going up, and so your cost of goods sold is going to be lower under FIFO, which makes you look more profitable. But when they talk to the tax man, they love to talk in terms of LIFO because if your cost of goods sold is higher, then your profit and hence your tax is lower. So that's where you're left with at the end of Q2. We add our Q3 production, and then again we're going to sell 11 units, so we'll sell 5 of these plus 6 of these, and we'll be left with this. So again, here our inventory is 320, under LIFO it's 250, and our cost of goods sold is 830, under LIFO it's 870. And then we add our Q4 production, and again we're going to sell 9 units, so it's going to be 4 of these plus 5 of these for a total of 770, and we're left with 5 units at a cost of 90 for a total of 450. And again, compare and contrast under LIFO, we've got mostly older units, so 3 left from Q1, 1 left from Q2, and then only 1 left from Q4, with a total inventory of 340. Under FIFO, we assume that all the units that are still in inventory come from Q4, so the inventory has a value of 450. So that is what we are going to be trying to model. And if we come back to this model, you'll see because some of the costs change, the materials cost changes in every quarter, the production time and hence the labor cost per unit changes at random times every time this trips over a new multiple of 100,000. So what you're going to have is 40 different unit costs over the 40 different quarters in the model. So it's going to be basically you're trying to build this, except instead of just 4 lines, it's got going to have 40 lines. So we're going to figure out how to do that. So that's the sort of conceptual introduction. Let's talk a little bit about, how in principle we're going to model it, and then we'll kind of dive into the details. So that's the chart here that I kept accidentally previewing. Chart is a bit of a strong word. So just ignore this one for a minute and think about this. And think of this as, basically your bucket, so to speak, of everything that you have available. So in other words, here, for example, this is after my Q3 production. I'm then going to sell some things, and under LIFO I want to sell the newest things, and under FIFO I want to sell the oldest things. So let's just say that this represents my inventory by vintage. So these are the first things I made, the second things I made, third things I made, fourth things, fifth things, sixth things I made. So under FIFO, you can basically imagine that as my sales go up along this bucket, at some point I'm going to cut across and say, okay, that's my total sales, which means I sold all of the oldest vintage, all of the next oldest vintage, all of that one, and then this much of that one. So if you think of that in terms of, a chart of, here's sales, and here's, how much of each vintage gets sold. So in other words, if my sales are only this much, then I sell, all blue, all the oldest vintage, and nothing else. If my sales are this much, then I sell all blue, all orange, all gray, all yellow, and a certain amount of lighter blue. So the thing to note is that basically each band has this kind of shape. So first none of it gets sold, then it goes up, and then it goes along like that. So a couple of things to flag on this. If you think about, just stretch out these three lines that make that up. Go that way, go that way, and go that way. And let's just say that the total value of all the inventory that gets sold before it is the total units, is just call that A, and call the total number of units available of this inventory B. Then what are these lines? Well, you've got a line here. If I just think of typical x-axis, y-axis, I've got a line here that's y equals A plus B. I've got a line here that's y equals A. Oops, A. And then I've got a line here that's just y equals x. And the thing to notice, let me just grab a different color pen for a second. The thing to notice about this is that the value that you want is always the middle of these three lines. So in other words, here, this one is the middle, and then it crosses, this one takes over, and that one's in the middle, and then this one's in the middle. And so from a modeling perspective, the function that captures this is median. So the median is the middle of some number of values, and in particular, if you've got three values, it's just the middle one. So if I think of this in terms of how much yellow is being sold, I basically need to subtract off A from everything, because this is up to here, I've got 0. So if I subtract off A, what am I taking? I'm taking the median of 0, which makes sense because you're never going to sell less than 0. Then take A off that, and I get just B. So in other words, it makes sense, you're never going to sell more than the total amount of the thing that you have. And then, sorry, let me just delete this and make some room. And then the other thing is X, your total amount of sales, minus B, the amount of sales, sorry, not B, minus A, the total amount of sales that come from earlier buckets. So in other words, if the amount of sales not covered by earlier buckets is less than 0, then I don't sell anything. If the amount of sales not covered by earlier buckets is above 0 but less than the total of what I have, then that's the amount I sell. And if it goes above the total of what I have in this particular yellow vintage, then I sell all of that vintage. So this formula here, the median of 0, the total amount you have, and the total sales minus everything covered before, is the sort of heart of how I'm going to model this. So enough chit chat, let's get implementing. So how are we going to do it? Oh, sorry, I just realized I need to add closing inventory up here. And that is going to be max of previous closing inventory plus units produced minus units sold and 0. So in other words, if I sell out, I sell out, although in this case I never do. I'm going to take that format, which I use to say empty cell being referred to, because this cell refers to that, but there's nothing in it. So it's just kind of a reminder to myself not to put like a row sum or something else in there. So lots and lots of preamble. Now let's get on with it. So let's start with LIFO, because it's kind of technically harder, but I find it actually a little more intuitive for how to model. So we're going to say quarter. It's just going to be the list of the 40 quarters, unit price. I'm just going to transpose my unit prices from up here, and then format it, and then I'm going to just put that there to say basically, everything starts off empty. And then I'm also going to put this along here. So what's that formula going to look like then? Well, first of all, how much of each thing do you have? Well, the answer is you have the previous closing inventory plus the amount produced if you're in the current quarter. So if this quarter is equal to this quarter, then you add the amount produced, lock in the row, otherwise 0. And so right now that's just going to show me, let's copy it all the way across, that's just going to show me everything ever produced. So you produced 55,000 units in the first quarter, I haven't taken anything away yet, so right now that just stays forever. 55 in the second, third, fourth, fifth, so on. Then at some point you're going to start producing more, and on down here. Okay, so that is sort of the equivalent of this piece here. It's like after you've added the production but before you've sold anything. So now what I want to think about is, how do I allocate this 30,000 among the available spaces? So in other words, start with, the first quarter is the simplest one. I've got 30,000 of closing inventory. The only place I can put it is here. So it's going to be median of 0, the total amount I have available, which is my no starting inventory plus my 55,000 produced, and then the closing inventory minus everything that's covered before here. And that I'm going to lock in the row so that that will expand as we go down. I'll just copy down so you can see here now I'm saying, well, right now there's nothing available in this anyway because we haven't produced anything in Q4 yet. But if I were interested, if there were anything in that vintage, well, I would be saying I've already filled up. I've got 30,000 of closing inventory and it's already done here, so everything below that's going to be 0. So let's copy across and just watch how this behaves. So now I've got my available inventory before sales is 30,000 that carries over here plus 55,000 produced in this quarter, and then I want to allocate 45,000 among that. So I fill up the 30,000 and then I get 15 of the way into that next 50,000. Then we carry over. I've got 30,000 here, 15,000 here, and then another 55,000 that I produce in this quarter. And I fill that up from the bottom with 70,000. So first 30, then 15, and then the remainder, which is 25, goes in here. Then here I've got 65,000 to fill up, so I fill up the 30, the 15, and then 20 of the 25. So none of this, and that's because my units sold are higher than my units produced, so I end up with no closing inventory from the current quarter. And so it keeps on going like that. Our demand is highest in Q4 because we talked about this last time. It's quite seasonal, and that the seasonality was deliberately designed so that you would get this effect that like your inventory builds up in lots and lots and lots of different tranches. So you produce slightly more than the demand in 3 quarters of the year, and then you eat it away in the last quarter. And so your inventory builds up and up and up and up. Whoops, sorry. Did not mean to jump all the way to the end. Builds up and up and up and up and up. Let me just zoom out a little so you can sort of see the shape of it. Oh, sorry, I have not, I guess, copied my formula all the way, because that is not, yes, I have not copied my formula all the way down. So let's fix that. That's more like it. So you can see, if you remember, if you watched the video last time, basically what we had was, our initial production was higher than the average demand over the cycle of the year, and so we were kind of building up inventory. So you can see we kind of start off with nothing. We build up to like over 100,000, 150,000, and then as the demand catches up, and we try to keep our production not much ahead of the demand, we end up kind of eating away at our inventory, getting back down to lower numbers. And so what that looks like for LIFO is you build up this sort of repeated sediment. So the stuff you produce in Q1 doesn't, in the very first quarter of the model, never gets sold according to LIFO, and the stuff you produce in the second quarter, a little bit of it gets sold at some point, but most of it survives all the way through. But then you build up, like at one point you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You've got 11 different quarters represented in the closing inventory for Q3 26. But then as your demand gets bigger, you start to eat away at some of those older layers. So what you'll find is, if you look at, let me just zoom back in so you can see what I'm writing here. So what do we want? We want the value of closing inventory, and that's just going to be the sum product of the number of units times the unit cost. Just lock that and make that a 33. And cost per unit of closing inventory, and that's just going to be this divided by number of units. And so if I just very quickly kind of throw this in a chart, you'll see this kind of weird behavior, that it goes up quite slowly because it's anchored on the early periods, but then at some point when you start when you start to eat away, let's zoom back out so we can find it here. When you start to eat away those early periods, and actually more of your inventory is from later periods, then suddenly your average price per unit starts to catch up to somewhere in the region of what's actually being produced in that period. And once we do the FIFO one, we can chart that one as well quickly and sort of compare and contrast. So let me zoom back in. So the first thing we want is closing inventory, and the second thing we want is the cost of goods sold, and that is going to be, you can think of it as what do I want to say? Closing. Sorry, didn't want to put it there. I wanted to put that here. So it is the previous closing inventory plus the cost of what's produced in this quarter, which is this, minus the new closing inventory. I think I've got that right. I hope I've got that right. And then cost per unit for the goods sold. That's going to be this divided by the units sold. So you can see in the first quarter, there is only one price of unit, so the cost per unit of the closing inventory and of the goods sold is the same. But then as you move out, under LIFO, as the costs go up, that immediately impacts on your units being sold because they're the newest units, but it's much slower to impact on your closing inventory because a lot of those are much older. So here, for example, you've got your cost of goods sold is almost $620 per unit, but your value of goods in inventory is $520 per unit. So that's the kind of weirdness that you get under LIFO. That's all kind of assuming a cost increasing environment, but if you have a cost decreasing environment, then good for you, but not super common. So that is all the LIFO stuff. Let's quickly kind of reproduce it for FIFO. And now that we've done the sort of setup, it should be pretty easy to do that. So what do we need to say? E84, that stays the same. That stays the same. We're comparing quarter to quarter and adding that. Fine. And then closing inventory. So the only thing I need to change is the sum range being referred to. And what I'm going to do is I'm going to take this and copy it. Whoops, I'll just put in a line break. So again, I have this kind of hashed out area to represent empty cells that are being referenced. So under LIFO, I was saying, take away everything that is already covered before. under FIFO, I basically want to point it in the opposite directions. That's why I'm going to have an empty row here instead. So I'll just replace this with this, where I lock in only the bottom row. I think I've got that right. Let's take a quick look. Yeah, so now what you see is a much more typical FIFO pattern. There's, you don't have lots and lots and lots of different quarters. The most you'll ever have is, in this case, like 3 or 4 or so. Why is there nothing here? That's not good. Do we sell? No, we don't. Okay, that's concerning. So here under LIFO, I have things that add up to 105,089. Under FIFO, for some odd reason, I don't, and it should be here. So why isn't it? Let's take a quick look. So I'm between 0 and the number of units. So that's my 110,000, fine. 105,000 minus the sum of those, which is 0. So why? That's very weird. So I've got the median of 0, 110,000, and 105,000, which for my money is 105,000. What on earth is going wrong? Maybe there's some circularity it's unhappy about. Sometimes makes it not calculate. But I think I fixed it. Let me just clear out these formulas for a second. So just quickly check 140. So that one's working. What? This is really weird. Ah, okay, sorry. Yeah, I see what's going wrong. Sorry, got to plug in. I see what's going wrong, and it's that my reference is off by 1. Fine. So that shouldn't be too hard to fix. So $123. Yeah, sorry. Okay, so when I expanded it down, I only went down to 123. I needed to go down to 124. And that meant it was not behaving in the correct way. It thought there was a circular reference when I got down to that last row. So I copy across. That's better. Okay, so now I've got that. Let me just do, since that's acting weird, let me just do a very quick sense check. Sum of that minus my total closing inventory. Whoops, sorry. And that is indeed all zeros. Okay, good. So now my closing inventory, I could have kept those formulas, but I deleted them while I thought something else was wrong. So let's just do it again quickly. Lock that in, and then move that down to 84. Then we'll do this divided by closing inventory. Copy across. And then the COGS, same thing again. It's going to be the opening inventory plus the total cost minus the closing inventory. Copy that across, and then it's going to be that divided by sales. And so now I said we'd compare and contrast the shapes of the. So yeah, here you see the cost. Sorry, the cost per unit of closing inventory under FIFO is very regular, and the cost per unit sold also very regular. So now let's just quickly see if I've actually done the calculations right. So I have the questions: closing FIFO inventory Q323. That is closing inventory is here. That's good. FIFO COGS in Q428. Jump across. Q428 cost of goods sold. That checks out. When is the last of the units produced in Q225 sold under LIFO? So I'll jump up here. Q225 is quarter 10. So when is the last of these units sold? And the answer is it's sold in Q427, which is indeed what's there. Okay, closing LIFO inventory in Q327. Oh yeah, so this is me being a little bit mean, because remember I told you there was one quarter that had 11 different vintages in it. So closing value of inventory, there were no shortcuts there. and then the quarter with the biggest dollar difference between FIFO and LIFO inventory. So FIFO versus LIFO inventory. I'll take the absolute value of this minus this. So again, it's 0 in the first quarter because in the first quarter you only have one value, so it doesn't matter what inventory method you use. So then, what do I want to say? I want to say match max of this against this, comma 0, and it's quarter 23, which is Q3 of 28, and that is indeed right. And the average closing inventory under LIFO. It'd be very embarrassing if I got my own question wrong, all things considered. But I didn't. Good. All right, so that's the last piece. Yeah, I think that's all I've got. Like I mentioned on the last one, I usually get a few extra people coming around when I'm doing recent FMWC stuff. So if this is the kind of thing you're into, you like problem solving and or some technical modeling stuff in Excel, then that's the kind of thing I do. Feel free to subscribe, or maybe pass this on to somebody else who would be into it, and help them find me. That's all I got. I'll see you next time. Have a good weekend.